Welcome to a new episode of the Sustainable Living Podcast. I'm your host, Nicoleta Talpeș, and today's conversation is a deep dive into the intersection of artificial intelligence and sustainability. I'm joined by a distinguished guest, Ricardo Vinuesa, Associate Professor at KEITH, Royal Institute of Technology and Lead Faculty of the Climate Action Center. Ricardo is also the author of a landmark study published in the Nature Communications, which examined the AI impact on all 17 UN Sustainable Development Goals. Ricardo, thank you for joining us and welcome to Sustainable Living Podcast.
Thank you for the invitation. It's a real pleasure to be here.
Let's start with the broad question. In your view, what is the most meaningful way artificial intelligence can contribute to building a more sustainable and equitable future?
Yeah, what we found out in that study, where we put together a very complete team of researchers, 10 people from all over the world, looking at each of the targets from the SDG agenda. What we found is that generally, if we oversimplify things a bit, so AI is enabling capabilities that were not possible before. That's kind of like the main underlying feature of why 79% of the 169 targets can be enabled through artificial intelligence. This can be from having more efficient usage of building energy, from being able to to match supply and demand of energy, to maximize the usage of renewables, from really being able to operate renewable energy in a much more efficient way. So all of these features have in common the fact that are enabled by AI and were not possible before, at least not so efficiently.
I see. At the intersection of AI and environmental science, how can machine learning can help tackle complex challenges like climate modeling, air pollution, or energy optimization?
Yeah, one example, and this is something where we have several large EU projects, is on pollution in cities. So one of the things where we can really have quite some potential from AI is, for example, to be able to locate sensors in optimal locations to get the best reconstruction of the flow and the pollutants in the city. So imagine having at a neighborhood level 10, 50, 100 sensors distributed across the neighborhood, and from those sparse measurements, reconstruct in 3D what the velocity of the flow is doing and where the pollutants are located, right? What's the concentration of pollutants? Now, with that information, you can, first of all, have actionable items. You can really say, look, this source should be delayed or should be moved this way. The traffic should be controlled in this manner, should be rerouted to avoid these hotspots of pollution. And even one can think of active control strategies. There's some research that is showing how to dynamically open and close windows in different areas of the neighborhood, such that you can enable flows of air in and out that can affect these levels of pollution in the city. So this is just one example. We're really going very deep into it. And that's certainly something where the great capabilities of AI and predictive power and optimization can really, really help.
What AI advancements do you find most promising for accelerating the green transition, especially in sectors like transport or urban infrastructure or industry in general?
Yeah, I work a lot in my research with, it's very related to the transport sector. I work a lot with aerodynamics and fluid mechanics. So I really try to make aircraft more efficient, cars less pollutant, ships, trains. And in the past years, we've really been able to, first of all, come up with much better ways to represent the air around the vehicles or the water around the vehicles. Explainable AI. This is something that is a game changer for us because it's really enabling us to identify key physical mechanisms that are really driving the friction between the air and the surface of the vehicle. And then deep reinforcement learning is a strategy to really find ways to control and manage the air around the vehicle in ways that were unprecedented and very, very efficient. So in a way, I think the game changer for us in the context of transportation is the combination of explainable AI to identify what are the most important regions to focus on, and reinforcement learning to come up with very efficient control strategies to tackle those areas.
Ethical concerns around AI are growing, and it is a question that I address to all our guests, particularly in terms of privacy, inequality, or biases. So, from your perspective, how do we ensure AI solutions designed for sustainability are also fair, are also inclusive, and trustworthy?
Yeah, that's something that we already talked about in 2020 in this study that you mentioned. 1 year later, we published in Nature Machine Intelligence a piece on how, if you want to use AI for sustainability, you need to have interpretable models. Explainability is key. So this is kind of like the first step to auditability, but also to have trustworthy models that can really help us to make a difference in these applications. So I would say that explainability is one of the keys. Perhaps the other one is in terms of data privacy. I mean, now, depending on which large language model you're using, your documents that you're putting in your LLM, your data are being sent to companies, right? And nobody really knows exactly what they're doing with those documents. So perhaps having more decentralized and local deployments or certain language models where the data can remain secure should be something that we should prioritize as well.
Transparency and accountability are essential for public trust in AI systems. So, what approaches would you recommend to improve explainability to AI tools used for environmental policy or social decision making?
Yeah, there's kind of two directions in this context of explainability. One is with feature attribution methods, which is a very classical approach, in which you're basically from your data, you're making a decision from your data, right? So from your data, you identify what parts of your data are the most critical, are the most informative to the output that the model is making, right? And then that can really inform not only the model itself and how the model is designed, but the whole pipeline. If you're using some AI model to identify features from images, and you use that to make a decision about some power plant or some action, governmental actions in certain areas, you should be able to understand what parts of your data are telling you to make that decision or that other decision. So that would be about feature attribution. And there is another direction which has to do more about coming up with equations they're obviously interpretable, right? Algebraic equations that can somehow replace or even perform even better than the deep learning models that we are using. And that has to do with combining deep learning, inductive biases, and symbolic regression. So there's tools with genetic programming, with sparse identification of nonlinear dynamics. There's different ways where you can combine deep learning and symbolic regression such that you can, in some cases, come up with equations, and that certainly helps a lot the interpretability.
Let's go back to your study. You and your co-authors evaluated the AI's potential impact on all 17 and sustainability goals. Which goals are currently benefiting from the most from AI, and which are the greatest risk of harm due to its misuse or unintended effects?
So all the 17 goals can benefit from AI, and 79% of the targets, which are the sub-goals, can benefit from AI. 35% of the targets can be negatively affected by AI, which in principle, this tells us that there is a bit of a positive message, right? Because a lot of the targets can be positively affected, but we should not forget about the negatives because of the cascading effects. I mean, you may have one target being negatively affected, but because the SDG, the Sustainable Development Goal agenda, is highly interconnected, one being negatively affected can cascade into many others later. So that's something important to keep in mind. In the positives, I remember that the ones related to sustainable cities, clean energy, many of the environmental goals, even SDG 1 on no poverty, those were some of the SDGs with the highest degree of positive impact. The ones with a highest degree of negative impact, I would say that, for example, reduce inequalities. right? I mean, that's clearly something that we are already experiencing. We already forecasted that in 2020 when we published that study. So if the future is going to rely on AI, right, and not everybody has the same type of access to AI, we're going to exacerbate the existing inequalities. So that's certainly something that we should be very aware of.
Looking ahead, what actions or collaborations do you think are most urgent, whether from academia, government, or private sector, in order to ensure AI support both societal and planetary well-being over the next decade or in the future?
Yeah, some of the most recent work that we are doing, we're very excited about, is using AI to basically develop the future of the SDG agenda beyond 2030, right? I mean, we are already less than 5 years, to the goal of the 2030 goals, and then what, right? So we have been working together with Google, together with the UN, on trying to come up with an agenda that would be streamlining the goals that we have from the SDGs, the goals that we have from the planetary boundaries framework from the Stockholm Resilience Center, which are measurable physical quantities, and try to, in a way, combine and streamline both to create a new agenda, right? Which would be much more efficient and targeted, and an agenda that can synergistically tackle numerous goals. So I think one of the key directions is to rethink basically where we are going at, right? The goals that we have, we need to rethink the agendas, and AI is helping us a lot with this.
Ricardo, thank you so much for joining us today, and thank you for sharing such insightful insights into how AI can shape a better and a better future.
Thank you so much. It was really great, really fun to share these moments with you, and looking forward to the next time.